Welcome to Binary. Today we're going to look at how to convert a binary number into a denary number and a denary number into a binary number. To do that, we need to understand what a denary number is. So I'm going to write on the board a denary number that you will recognise. So let's go for 321. You recognise it because these are the numbers we use every day. You understand that there are 3 hundreds, 2 tens and 1 units. You know this because that's the way we learnt to count when we were younger. We used columns. So let's do the columns in this number. Okay. So we have in the first column the ones column, and then we have the tens column, and then the hundreds column, and I could go on to put a thousands column and so on, but I'm going to stick with 3 numbers. Okay, so this is how we learnt to count when we were younger, and this is called base 10 because what we are doing, we are going up by times in each column by 10. Okay, so this is base 10. So if we take the number 1, okay, we always start with number 1. The next column is 1 times 10 is 10. And then to get the next column, it's 10 times 10 is 100. And then we could go 100 times 10 is 1,000 and so on. Okay, that's base 10 and we call this denary. You know it as decimal, but in your exam it will be referred to as denary, just the numbers we use every day. Okay, now binary works very similar. It works on a base 2. So if I draw the same columns that I've got above, okay, I'll just put the columns in. We always start with a 1, same as we do with the base 10 denary. But this time I'm going up in 2s, so, or times in by 2. So the first column is 1, so if I times 1 by 2, the next column will be 2. And if I times 2 by 2, the next column will be 4. If I times 4 by 2, the next column will be 8. And I could go on, but I'm going to keep it simple with 3 columns. Right, so if I had a binary number of 101, you may look at that number and say, well, that's 101. And that would be correct if we were talking about denary. But this is binary. Now binary only has 2 numbers. That's a 1 and a 0. Let's just look at the denary, how many numbers we have there. Well, we have 10. We start with a 0 and 1, 2, 3, 4, 5, 6, 7, 8, 9. When it gets to 10, it moves on to the next column. Okay, so we only go up to 9. Now, in binary, and I'll just write binary here so we don't forget binary. Okay, so binary works on base 2. So we only have 2 numbers, a 1 and a 0. So in the first column we've got a 1. It can't go up to 2 because we either have a 1 or a 0. So if it does go to the next number, 2, then it moves on a column. Okay, just like we do with base 10. Now, if we have a look at this binary number 101, what do they all stand for? Well, a 1 means it's on and a 0 means it's off. What do I mean by that? Well, in your computer we have lots of electrical switches. They're either on or they're off. So 1 is on and 0 is off. So have a look at 101. Well, we can see that the number 4 is on because it's got a 1 underneath, and the number 1 is on because that has a 1 underneath. We ignore the zeros, so in this case we are just adding the columns together. So 4 plus 1 equals 5, and it's that easy. Okay, so this is binary. Okay, if you can imagine it like a little light switch, so when it's on it's 1, when it's off it's 0. Okay, right, so let me just get rid of this columns now, and I'm going to make some more columns. Okay, so if I start with our 1 column, okay, and then we're going to go up in 2s, so times in by 2. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, you just double in the number, 64 times 2 is 128, okay. So all we're doing is doubling the number. So if you can see here, 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 4 is 8, and so on. So if I just put them columns in, okay. Right, so I've got my columns, and say I want to find the denary number 26. Okay, so we're going to make a binary number that's equal to the denary number 26. To do this, I need to see what will go into 26. First column is 128. Well, that's far too high. It won't go into 26, so we can put a 0 there. 64 won't go into 26, so 0 there. 32 won't go into 26, so a 0 there. Now 16 will go into 26, so we can put a 1 there, and let's take 26 away from 16 and see what we're left with. So 26 minus 16 equals 10. So we're left with 10. So let's move on to the next column. Well, 8 will go into 10, so I can turn that one on. So let's do another sum. So 8, oh, should I say 10? Okay, let me get my rubber. Okay, so 10 minus 8 equals 2. Okay, so we've got 2 left. Well, 4 won't go into 2, so we can put a 0. 2 will go into 2, so we can turn that one on. There's none left after that, so we have a 0 at the end. So the binary number for 26 is 0, 0, 0, 1, 1, 0, 1, 0. Okay, how do I know this is correct? Well, first of all, look for the where you put a 1 underneath to just check. Okay, so we've got this one, and this one. Okay, well, let's add them together and just check that this is correct. So we've got 16 plus 8 plus 2, and that equals 26. The other thing to look out for is the end number here. Okay, if it's a 0, it means that the number, the denary number, is going to be an even number. If it's a 1, it's going to be an odd number. We can see it's a 0, so yes, our number is even. So that's another way to look. Right, well, what do all these zeros and ones really represent? Well, they represent bits. Okay, the number we've got here is 8 bits because there's 8 columns. In your exam, it will generally use 8 bits. However, it may do 16 bits, so get used to expanding your columns onto 16 bits, and all you have to do is take this number and double it. So your 128 times 2 is, and keep on doubling it until you've got 16 columns, and then you'll have 16 bits. Okay, so each bit, whether it's a 0 or a 1, okay, will be represented either in 8 bits or 16 bits. Hope this has helped you understand binary, and the next video will show hexadecimal.